Today we're taking a look at some sample problems from section 4-4. And in the textbook, those problems begin on page 164. And we will begin with exercise number 6. It says in exercises 5 through 12, determine whether the events A and B are independent or dependent. Find the probability of A and B, the probability that events A and B both occur. Okay, so in number 6, when a baby is born, it's a girl, that's A. B, when a second baby is born into a different family, it is also a girl. So those would be independent because the outcome of one child would be no different than the outcome for another child in another family. And so 1/2 is the probability of a girl being born in the first family, and 1/2 would be the probability of a girl being born in the second family. So our probability is 1/4 or 0.25. Okay, number 8. When a day of the week is randomly selected, it is a Saturday. And B, when a second different day of the week is randomly selected, it is a Monday. So in this case, they would be dependent simply because we're selecting a different day. So it's kind of like the idea of no replacement. So the probability of getting a Saturday, when one day is randomly selected, would be 1 out of 7. And since we've removed Saturday, the probability of then getting a Monday would be 1 out of 6. And so we have 1 out of 42. And let me get that as a decimal. It would be 0.02. So you could use either... No, that's not right. 1 divided by 42 is 0.0238. Okay, 0.0238 is what we have. Alright, number 10. We have A, when the first digit 0 through 9 of a 4-digit lottery number is chosen by someone buying a ticket, it is the same for stitches that is later drawn in the official lottery. So, okay, that's A. B, when the second digit of a 4-digit lottery number is chosen by someone buying a lottery ticket, it is the same second digit that is later drawn in the official lottery. Okay, so those would be independent. We're talking about two different digits. And the probability of drawing the same number is 1 in 10, and then again 1 in 10, so that would be 1 in 100, which is 0.01. Okay, number 12. When an M&M is randomly picked or selected from the 100 M&Ms listed in data set 20, it is one of the 8 yellow M&Ms. When a second different M&M, so that indicates that we're not replacing, is randomly selected from the listed, those listed in data set 20, it is also a yellow M&M. So we have 100 M&Ms, and there are 8 that are yellow. So it looks like it would be dependent since it's saying a different one. So that means we're removing it, so we're doing the drawing without replacement. So we have 8 out of 100 times 7 out of 99. So 56 out of 9,900. Would be 0.005656, so 566. Number 14. This is a different group, and we're using the Table 4-1 that's at the top of the page, and it says pre-employment drug screening. Okay, and we're to consider an unlikely if the probability is 0.05 or less. So if 3 of the 1,000 test subjects are randomly selected, find the probability that they all had false negative results. Is it unlikely to randomly select 3 subjects and get 3 results that are all false negative? Alright, so in part A, we're to assume that the 3 selections are made with replacement. So they would be independent. So we can use the same probability. So we're looking for false negative. There were 6 out of 1,000. So 6 out of 1,000, or 0.006 to the third. Gives us 2.716 times 10 to the negative 7. So we need 6 zeros. We're moving our decimal point 7 places to the left. And then our 216. And it would be unlikely. That's a very small probability, way less than 0.05 without replacement. Okay, we're going to get 6 out of 1,000 times 5 out of 999 times 4 out of 998. Okay, so 6 divided by 1,000 equals times 5 divided by 999 equals times 4 divided by 998. And I'm getting 1.20 times 10 to the negative 7. To the negative 7, so that means, again, 6 zeros. And 120. So, and there again it's very small, so again it's unlikely. Okay, number 16, we're using the same table. If 4 of the 1,000 test subjects are randomly selected, find the probability that they all had true negative test results. Is such an event unlikely? So with replacement is part A again. So true negative would be 860 out of the 1,000, so that's 0.860 raised to the 4th since we're selecting 4. And that's 0.547. No, it's not unlikely. This time it's way more than the 0.05 that we're comparing it to. So without replacement, we have 860 out of 1,000 times 859 out of 999 times 858 out of 998 times 857 out of 997. So 860 divided by 1,000 equals times 859 divided by 999 equals times 858 divided by 998 equals times 857 divided by 997 equals, and I'm getting 0.546. Okay, 0.546 again would be no, it's not unlikely. Because again, it's more than half. Okay. Let's move on to number 18, which is acceptance sampling. This is a very common practice to set up an acceptance sampling. And I'm going to read part of 17 to explain what it is. With one method of a procedure called acceptance sampling, a sample of items is randomly selected without replacement, and the entire batch is accepted if every item in the